Hello viewers, welcome back to video tutorial on AgentGrid. In this series of video tutorials, we were explaining you various patterns of agents using AgentGrid SDK. And in this video, we'll explain you what is workflow. So the concept of workflow using AgentGrid SDK. As usual, we'll take a simple examples. So in this video tutorial, we'll take a simple or a sequential pattern. The use case is a legal contract review, and that will be dealing in workflow concept of AgentGrid SDK. So this demonstration walks through with how to build and orchestrate sequential workflow of agents using AgentGrid SDK and AgentGrid's Workflow Engine. So we focus on a legal contract review workflow where contract passes through 5 different specialized agents in a sequential fashion, and workflows basically helps in binding agent flows without hard coding any details in the code. So if you have seen our previous videos, we used to write who will be the next agent from this agent. So such kind of hard codings, either we used to do it in code or we used to do it in YAML files. But in the workflows, we'll not be directly doing it in YAML files or maybe code. But what we'll do it is in we'll create a workflow file, and we'll establish a workflow file. We'll register a workflow, and we'll deploy that workflow, and that the deployed workflow will take care of running those agents one after the other based on the diagram or a DAG concept that you have given in the workflow. So here there is no we will not use the YAML or in agent code where allowing the path of a data movement to be constructed dynamically at runtime. So let's get started with the workflow. So before going to workflow, so let me just show you the directory structure of this example code. So earlier we were using a different directory structure, but right now since it's a workflow, I have created a separate code base. So we have agents LLM and agent SDK that we have already we have shared same thing that was earlier available. It is it's no difference, it's same. And we have two folders here, multi-level workflow and simple workflow. In this video, we'll dealing only with the simple workflow, and here some utility files and also some bash scripts and entry points where we will be using this build bash files for building the Docker containers required, and entry point.sh is a entry point for all the source files. So whichever the agent runs, right, so it has its own entry content on the entry point.sh. So in this if you go to simple workflow, we have a deploy and run, nodes and spec. So this nodes folder will contain the Python codes of all the agents. We have totally 5 agents in this example simple workflow, where the first agent is clause extractor agent, risk identifier agent, compliance checker agent, negotiation advisor agent, and legal memo agent. So those source codes are present in the nodes and spec, where it contains the registration files, the JSON files needed for all the A5 agents. And and also in the spec file you have some scripts which will help us in deploying those agents or removing those agents and registering and unregistering the agents. So all those bash files are present in the spec folder. And in the deploy and run folder, you have a important file known as workflow spec.json. So this is the specification of the workflow, where you have how the DAG structure of the workflow is, and we have some the bash files which are required for us to do the registration, deploying, again removing and unregistering the workflows. So those bash files are present in the deploy run folder, and also some Streamlit app, so that we can visualize the data movement from within these agents one by one. So that also we have in this deploy and run folder. So let us get started. Before explaining the getting into the demo, so let's explore the files present. So let me just go to this spec file. So I opened all the files here, so let me just open the spec. So here is a spec file of one of the agent clause extractor.json. So here main thing that I am interested is only the agent subject ID and subject name, and other things I have not filled. I have kept on general, and one other important thing is a Docker image. and rest things remains almost common for all the agents because I have not modified those contents. And in the persona you will have a default message that is also not so useful for me right now. And also we have a configs, and also in the integrations I have a model section where in the models we have an our AI OS based block LLM, the Quen 3.1 1.7b block, which is hosted using VLLM, and its parameters are present in the model section. So in the model section we can have multiple models as well. So other things that I have not touched, so they are not right now useful for me, so I have not modified those. So this is the content of one of the agent JSON file. So this will be same for all the agents except the subject ID and subject name, and the docker name might change for rest of the JSON files. So now let me go to the code directly. So we have the first agent, as you can see, clause extractor agent. So let me just open the clause extractor agent. Yeah, the clause extractor agent. So as you know, our code structures, we have we are using a DSPy, and we require a DSPy signature class. So it has some doc string. Now the doc string becomes the system message of the LLM whenever it is about to use this signature. So that becomes the system message. So basically this clause extractor agent, we are asking you, hey, you are a legal clause extractor specialist, and given a contract text, extract the and categorize every clause into the following categories. So the payment, you need to extract the payment details, termination details, liability details, data ownership, SLA, renewal, jurisdiction, and respond only with the valid JSON. So whenever we give an input, from that input it has to extract these fields from the input. So we have a signature here, we have a module here, and we have a agent payload processor, which is basically to parse the input. So the input that we'll get in terms of agent task class, and output that it has to go from this particular agent is a agent result class. So whenever we get the agent task, we have to break that, and we require whatever the data we want, right? So that we need to extract from that, and we need to use that data. So this class will help us in breaking the give input coming to the agent. So this structure, and also we have a model context manager where this class will help us in providing the context to the DSPy class, the LLM object basically we need to pass on. So this function here, the self AI OS LLM get user model, and given the model name, it will help us in pulling up the block AI OS blocks object, and that object is set as a context for the DSPy to do the inference. So this class will help in that context. So basically the four things that you saw, the signatures, the modules, the agent payload processor, model context, it remains same in every agent file. So I'll not repeat again in all the files. So the clause extractor agent, so we have a subject and context object, and this subject is basically whenever we do a registration, right? So all the registration content will be available in the subject, and the context will get a few things that is needed by for housekeeping stuff, like if you want to talk to the next agent. Earlier we have seen this, we were using a different 2 to 3 kinds of communication, direct, peer-to-peer, and delegate methods. So whenever we wanted something from such kind of things, right, that AI AgentGrid is providing, so any such services you want, so those things are present from this context. So right now this is not required, and these all are the initialization of this classes that we have seen in the top. So here as soon as we there is no muxer is none, and in the on process also we are not doing much thing. So on data is called whenever input is coming to the agent, then on data function will be called, and in the on data, so you are just breaking you are checking whether this has this particular key. If this is the key, then it is the final it's not required basically. Right now it's not required, so you can ignore this. So we are breaking down the input, and whatever we wanted, right, we are just taking it, the raw contract. So from the raw contract and communication, model name, session ID, all those things are broken down, and from the raw contract, so we are just passing it on to the so I'm just logging into the the human intervention system, where I'll be using this to see what is input and what is output. So I'll not be doing anything with that content. I'll just put it in a dashboard so that you will see what is the input coming to this agent and what is the output going from this agent. So the input will have an incoming task as a task type, and the output, whatever goes from this particular agent, will be having a outgoing result as a task type. So this is at the input side, and another is at the output side. So then we'll do execute worker, which basically does the inferencing task. So given the raw contract, so it gets the result, and from the result we are trying to extract the JSON from it, and then we are getting the clause key and clause count key, and then we are formulating the complete output of this particular agent, and then we are dumping it into a his, and then we are returning it. So there is no mention of who is the next agent here at all. So the agent result that we passed, our workflow will take care that it will pass this output to the next agent, whatever the agent we have defined in the workflows. There is no agent to agent information here in the code. We are not writing those agent details. So this is the first agent. So let's see the risk identifier agent. So the risk identifier agent, it has again a same structure, so no difference at all. So if you see here, the input comes, you break down the input, push it into a his module, then do an inference, and just parse it, and once it is done, so you get the output that you wanted, and dump it in a JSON and send it to the his module and return it. So there is no mention of anything related to who is the next agent. So only the signature is having a difference here. So since it's a risk identifier, you are a senior legal risk analyst specializing in commercial contracts. So you will be given with a set of extracted contract clauses, and for each clause present, so the clauses will come from the previous agent here. So we have certain clauses like payment related clauses, termination clauses, liability clauses, data ownership clauses. So for each of these clauses, this risk identifier has to identify the risk. So what is the clause type, what is the severity, what is the score, 1 to 10, 10 is the most dangerous, findings, basically a reason, what is your concise one-line description of this risk, and reasoning, 2 to 3 sentences explaining why this is risky. So for each and every clause that it identifies, it has to identify this risk involved in those clauses. Also compute the overall risk score 1 to 10 as weighted average across all the risks. So this is the signature of this agent. So the third agent is a compliance checker agent. So right now the application's result is not that important for me. My main intention of this video is to explain you the workflow concept in AgentGrid. So we have taken, like, you can use any of the serial, or since it's a simple, I'm using a sequential agent. We could have used the first agent example as well, the sequential agent that we have used in our previous videos. That also I could have used, but here I have taken a simple other example. So compliance checker signature, you are a regulatory compliance attorney specializing in GDPR, CCPA, and Delaware contract laws. So you will receive a list of identified contract risks. So the risk identifier, the output, right? So it will come to this particular compliance checker agent. So for each risk, determine whether the associated clause is compliant with the applicable regulations or not. So you have to give you have to identify clause type, regulation, status, details. You should this is the output that is we wanted from the each finding. So it will provide basically an array of dictionary for each and every clauses, and so again the rest of the structure remains same, so I'll not explain those details again. So the fourth agent, negotiation. If any negotiation is required, right, so this agent will try to do a negotiation. So you are a commercial contract negotiation specialist representing client's interest. You will receive an identified risk and compliance finding for a contract. For each significant issue, produce a concrete red line, a specific suggested replacement clauses that protects the client. So it basically has to do a negotiation task. So for every clauses, it has to find some how to protect its client. So it has to identify it and it has to give those details. So here clause type, priority, original, suggested, rationale is given here. So this is the fourth agent, negotiation advisor. So legal memo agent. So it has to find, you are a senior legal counseling, drafting an internal memo for a client's legal team. So you will receive a full contract analysis including extracted clauses, identify risk and compliance finding, and proposed red lines. So produce a concise professional legal memo with the following section. So it has to basically act as a summarizer. At the end, it has to write a memo to the client, right? So it has to act as a summarizer by taking all the output and bringing few important points for the client. So this is the fifth agent. So let us see these agents in action. So as I told, we have to register the agents. So we have to build the agents first. So let me just build the agents and push the agents to the Docker registry. So let me just run this. So this bash script will take care of running the building the each and every Docker container required, and by passing the proper agent ID into the building Docker argument, it will be sending the each and every agents. So based on that, the entry point.sh will decide which Python file to call, and it will also after building it will push to the registry as well. So it is done for all the agents. It has pushed the Docker registry. Now we have to register this agent. So what this registration file will do is basically it calls all the JSON file that we have, and it will just do the registration to this particular API. It will do the post, and /API subjects is the root. So let me do the registration. Yes, it has done the registration for all the agents now. And next is the deploying of agents. So once registration is done, so basically those agents will be available in DB, so they will not be having a container or a pod. So to bring the pods into action, so we require a deploying. So what this deployment agent does, so deployment agent, it calls one API /API deploy agent deployer 111. So here deployer is responsible for all the housekeeping stuff of a pods of a agent. So this will take care of starting the pods of agents, deleting the pods of agent, whatever the env we need to pass on right from the system side. So all those things will be taken care by this deployer. So you can have multiple deployers per project, but right now I'm using one deployer. The deployer name is deployer 111, and I'm using this deployer to deploy all the 5 agents. So here in the agent registration time, you have to do a post operation. The API is API. The root is /API deploy agent deployer name, and you need to provide subject ID. The subject ID is nothing but the subject ID of the agent that you are registered. And you need to give the allocation details. In the allocation detail, we have a delegate API URL and mesh. So these are used for the communication. So delegate endpoint, delegate communication, or a peer-to-peer communication. So these entries are used. And instance. So basically, how many instances you want to create? It's an array. So you can create multiple instances, but for timing, I'm creating one instance. So the instance name would be I1, and this is the subject ID. So similarly, I'm doing it for all the agents, like say compiler, compliance checker agent, legal memo agent, and negotiation advisor agent, and then the risk identifier agents. So once we run this, you will see a registration success message. So I have done it already. So yeah, so once you run this, right, so it will show you a registration success, and agents you can see they have started like a few seconds back. The executor agents are there, and also the 5 instance of those agents are also present here. So now let us let us do an registration of workflow. So before registration of workflow, so I need to show you the workflow content. So this is the workflow spec.json file. So it has an header and a body. So let us see the header. So in the header, there is a name, version, and release data. So these 3 creates an uniqueness to the workflow and metadata. So any descriptions you want. Right now, I'm not so concerned about the metadata. So in the body, there is an array of variable known as nodes and a graph. So the key is known as nodes and graphs, and this nodes key is an array. It has 5 items because we have 5 agents, and it is a graph. So how those nodes are connected are defined in the graph section. So let us see the node. So there are 5 items. Each items has a node ID type. So this type could be a agent, it could be a policy, or it could be a workflow. So what this workflow means is a nested workflow pattern, like one workflow calling the other workflow itself. So those types are possible: agent, policy, and the workflow. So this is the ID. So this is the ID of the agent, the subject ID of the agent, and this node ID here refers to some name I have given for in this particular file. So this name is only meant for addressing any anywhere usage of this. If you want to use this anywhere, right? So to address that, I will give my some names. So that's what, like, I have given my clause extractor agent. So some name I have given here. So that becomes the node ID. But this is the subject ID of the agent, which this ID, this node ID belongs to which subject ID. So that this is what very important for us. So this is the first node. So you can provide its settings also. So model name, some dummy settings I have given here. So similarly for the next agent, so risk identifier agent, my risk identifier agent is the node ID, which will be locally used. And similarly for the third agent, fourth agent, and the fifth agent. So all 5 agents are defined like that in the node section. And in the graph section, so how these agents are connected. So right now it is a simple one-to-one communication, meaning after the first agent, the second agent will be there. After the second agent, third agent will be there. It's a serial sequential fashion, right? So clause extractor agent, risk identifier agent, so they are very sequential. So so my clause extractor agent will talk to the my risk identifier agent. So for this is the input and this is the output. So that kind of connection I am mentioning here. This is the input and this is the output. So I mean this is the first agent, this is the second agent. So that kind of workflow is defined here. So this is the first agent, this is the second agent, this is the first for the next agent, the my risk identifier agent, and this is the it has to connect to this is the agent, it has to connect to compliance checker agent. So compliance risk identifier agent has to connect to compliance checker agent, and compliance agent checker agent has to connect to negotiation advisor agent. So my compliance checker, it's talking to my negotiation advisor. So this is not the subject ID, it is the ID, that node ID. It is only local to this particular file. So this my legal memo agent, my legal memo agent is the final one. So this is basically the graph. So by understanding this will be this structure detail, the JSON structure will be given to the during the registration of the workflow itself. So now we have deployed the agent. Now I'm going to register the workflow. So to register the workflow, yes, so this is the this is a deploy register workflow. Okay, so this is the command /API workflows. I need to do a post operation and I need to give the content of the spec file. So what happens is, so now the content of the spec file will be registered into the DBs by checking the structure, whether the structure is fine or not. If any keys are missing or something like that, right, it might throw you an error. So right now in my spec file is a complete spec file, so it will not throw the error. So let me just do a registration. So yes, so it has finished the registration, it is success. Now once the registration is done, it is simply present in the DB right now. So I need to deploy it, meaning I need to connect those agents and I need to I need to make sure that it is ready for accepting any input from my side. So that's where a deployment of workflow comes. So in the deployer workflow, so you need to use the deployer, the same deployer I'm using it, and so you need to provide some names here: deployment name, workflow ID, some unique workflow ID you have to give, workflow URI. So this is the URI that I want to use it, like this URI is coming out of the workflow. So you can see here, this is the URI of the workflow, legal contract workflow 1.0.0 stable. So that's what is required in the workflow URI. So this you need to mention complete URI of the workflow, and in the allocation you need to pass on this information. These are basically envays that goes to the workflow deployment. So once this deployment is done, what happens is it will create a one pod in a new namespace known as workflow is the namespace. So let me run it. So there are some pods are already running in it. So once I run this, you will see one more new pod will be created, and that pod will take care of the whole running of a workflow. So it will get the input, it will receive the input, it will understand who is the first agent, who is the second agent, how the agents are connected. So it passes that JSON file and it passes on the input from one agent to other agent. So let me just deploy this. So it has deployed. So this is the complete output of the registration file. So what is important here is the URL. So this is the URL of the pod that you have got here. So let me just run this pod again. So here we have simple sequential workflow. This is the newly pod created 11 seconds back. So now this pod is the entry point for us. So if you want to talk to this pod, so you need to pass on any informations here. So that's it. So this is how we have started the workflow pod now. And before running the inference, so let me start a Streamlit dashboard. So I have a dashboard here. It's not running yet. So let me just run this app cell. So yes, the dashboard is started. Let me just refresh the dashboard. Yes, so this is a simple dashboard. It has 5 agents. So under one agent, you will see what is the input and what is the output. Similarly for all the agents. So Streamlit app started, and let me show you. Let me start the input. So in the input, so I'm so basically, as I told, we require this URL. So that information is required. So I have a this particular piece of code will do that. It will try to hit to it will give the URI of the workflow. It will give the it will basically give the URI, and it will try to pull the some information, and that information is the URL, and that URL is the workflow URL we call, and we have an API execute function, and you will be passing on a input. So input known as a text key. So this key is what passed from the first agent. So the first agent is a clause. So as you can see, the payload, right? So compliance checker, clause extractor. So this is the first agent where it will basically pass the text from it, and then it will passes on that raw text to the first agent. So that's why we are passing the text key here. So the text key and some input. So contract SaaS subscription agreement between some corporation to vendors, and key clauses: auto renewal at 15% price increase, no SLA guarantees, data ownership ambiguous, termination requires 180-day notice, liability cap at 5,000 regardless. So from this data, it has to break down. It has to identify the clauses. The first agent has to identify the clauses. Then second agent risk involved in it. Then it has to the third agent will be like a compliance checker, whether they are complying to some of the compliances like GDPR or any other compliances, then a negotiation advisor, and then a legal memo, final summarizing agent. So that way the data has to pass. So let me run the input now. Yes, so this is the URI of the workflow pod, and we have given the head. So it might take some time. So let us see in the dashboard. So as you can see, there is an input and output from the first agent. So this is the input and this is the output. This output will go to the next agent. So that is present in here. So let me refresh again. Yes, the second agent also has given the output, and it has given the input for the third agent. So third agent is also done. So this way each and individual agent will run it, and let us see the output now. So this is the input. The first input is a text key, contract SaaS subscription, and the task type is incoming task. So the output of this agent is, it has identified the clauses. So here is the clauses. Total 7 counts are there. Payment clause from the text, termination clause, liability clause, data ownership clause, SLA, renewal, and jurisdiction. So this is the clauses that it has extracted from the text. So this will be passed on to the next agent. So that's what the same input, same content is present here as well in the next agent's input, and next agent output will give the risks associated with each of the clauses. So it has given, okay, clause type data ownership high, ambiguity in data ownership may lead to dispute in legal challenges. So it is giving finding in one sentence or one or two sentences in reasoning. So it is giving for each and every clauses what is the finding and reasoning. It is also trying to give one score to it, and at the end it has added one overall risk score as well as a high risk count also it has added. So this is the output of the second agent. So this output will go to the third agent as the input. The input is here, and third agent output will come here, and let us see the third agent's output. So it has also added one more compliance finding as a new key it has added, and it is basically adding telling like what all regulations it has passed, data GDPR article, at risk, statusing at risk, the ambiguity in data ownership may lead to disputing challenges. So it is giving the compliances like which they are complying to. So this is the output of the third agent. For each and every clauses it is giving an compliance status. So next, the fourth agent output is it added the key known as red lines. So data ownership priority is high, ambiguity in data ownership shall clearly define the GDPR article 22 with specific responsibility suggested and rationally. So it has given the content. So right now the model that we are using is a Quen 3 1.7v model. So it has done some good amount of work. So if you have a specialized models to do compliances, or if you have a specialized model to do something which has dealt with the legal kind of thing, right? So we can use that model as well. So now we have got output of all the agents. So let me show you the output of the final agent. So it has to create a summary kind of a thing. So final memo, and it has given the contents here. So executive summary, key risks, compliance issues, recommended red lines, recommendations. So we need to negotiate the contract. So next steps. So this is the output of the agent. So I'm not so concerned about the output here, but I just wanted to show you the workflows. So now the workflow has started. Workflow has given the output as well here. So once workflow is over, it is showing the output. So it took almost 1 minute 5 seconds to get the output. And once we got the output, right? So if you want to kill it, so if you want to remove the workflow, so you can run this run this bash file. So it will simply remove the workflow, deploy and remove the workflow, where you need to pass on here to the deployer /API remove workflow, deployer name, and the workflow ID. Workflow ID is a simple sequential workflow 001. So if you pass that, it will remove the workflow. So let me just remove the workflow. Yes, the workflow is removed. So let me just check the pod's presence. So it is in a terminating state. So it will go now. So once workflow is removed, so if you don't want that pod, you can remove it. And if you don't want to if you want to remove the content of the DB also of that workflow, right? So you can do an unregistration. So unregistration, again, it takes simply the register workflow, deploy workflow, remove workflow is done, and unregister. So you need to pass on delete and it's the API workflow, the contract, the workflow ID of the spec in the spec file, whatever the ID is there, right? So that you need to provide here. It will be deleted from the DB. So let me just run it. It has deleted successfully. And then if you want to remove the agents, we have a remove agents.bash. So remove agents will have simply do post operation /API remove agents, and all the 5 agent details are present, and we are talking to the deployer 111 because this deployer only has deployed the multiple agents. So in the project you can have multiple deployers as well. So let me just remove the agents, and let me just check the pods in the agent namespace. Yes, they are in a terminating state. So if you want to remove the registered agents also, right? So you can run this file. So it will basically remove it from the DB as well. So this is the whole notebook for running the simple workflow, where one agent is talking to the second agent, and the workflow has taken care of passing on the information from one agent to the second agent without any hard coding in the code. So this is about a simple workflow. So in the next section, we will talk about a multi-level workflow, where one workflow itself calls one other workflow, and one other workflow might have several other agents which will be doing a specific task. So workflow within workflow, nested workflow, or a multi-level workflow we will deal in next video. So thanks for watching, and keep supporting us. Thank you.